All right, so let's see. So here's an experiment that basically very similar to things we discussed today. So allows you to kind of like get a better grip on the concept of the circular motion. So we're going to doing the looping roller coaster. Okay. So and understand that, and experimentally see that indeed the object, when it goes around in a circle like this, it has basically different speeds technically. So you can see, right, the learning objective is to use circular motion concept to analyze motion of a looping roller coaster. Okay. So in the video below shows a roller coaster, a looping roller coaster. So it says there's one tool in this video that needs explanation. The protractor tool can be scaled by clicking a corner of the tool. I'll basically show you that. So let's look at the motion first. So let's say what we have is that you have two, right? When it's 24 hours, 24 frames per second, normal speed, and also the slow one. So let's look at the fast one, first, and then we'll look at the slow one. All right. So basically, this is what we get, and our goal will be to measure the speed of the roller coaster at the bottom of, see, this is one circle. See, this kind of like circular path like this. So basically, how fast it's moving at that point. That means we want to know in terms of the speed at, let's say, at this particular point. Let's call this point 1, because it's at this point 1, it's moving with some speed. Or we can just, at the bottom, right? So this is the bottom, B for the bottom. Then what it does, it goes up and reaches the top circular part. And then you can see, right, then that's going to be basically the top part. So then we want to know how fast it's moving over there. So in a way, we have two circles, right? So one is much bigger circle, the other one is much smaller circle. But still, we should be able to apply, the circular motion concept to find the speed for both of those basically points, right? Point 1 and point 2 are the bottom and the top of that the circular trajectory. All right. So that's basically the goal of our experiment. So let's then look at some of the specifics. For example, if we change it to the slow, then it allows you to, basically it's moving so slow that you can just basically start making some measurements, something like that. Okay, so that means taking into account that you have two type of videos. So let's say what type of tools we have. So we have a protractor, and then we have two rulers. One is white, the other one black, depending on, if, let's say, if you have a hard time seeing this one, then you can then use the other one because, with the background that you have, right? So maybe this is better with the smaller circle, and this is a little better with the bigger circle. Okay, because we're going to need to measure the radius with these rulers. So then we're going to use the protractor and then the ruler to make the measurements. And the video itself, I mean, not the video, so the lab itself gives you some like, let's say, step-by-step guides. So for example, you're going to use the video and the timer to determine the speed at the bottom. And doing that, we're going to basically look, as you can see, right in the picture over here, it shows that you have the fourth, basically the fourth car. When it reaches that let's say this position over here, okay, that means we can then start. We can basically we can align with that green pole, pretty much the front of this car. Now, what we have here is, let's say, as soon as we have that, we can then just set our timer to 0, then measure how long it will take for this car to cover the distance of its length. Okay, and if we have that, we have the time, and then we can measure the distance, right? Because we're going to be told what is the distance of one car, the length of one car. That means basically what is this length, and then how long it will take for the car to travel that length equal distance, then we can say that this speed is equal to just the distance over time. Pretty much as simple as that. And then we can find the speed. All right, so then let's do this. So it basically tells you to take that and basically measure the time. So if you go back, let's say, so we're loading. See if I go, I can see like, okay, so then here's the first one passes. Here's the second one passes. Third one. And now I have the fourth one. Okay, then I take out my timer. I reset. Then I play the video. And I basically pause. You can see right now the fourth one crossed the distance equal, basically the front of the first one to the basically the front of the front of the fourth one to the front of the fifth one, I guess. That's basically close enough. Again, I didn't do anything. You can try to get a little bit more accurate. One thing you can do, you can just really zoom in and get a little bit better measurement, right? So for example, with this, I can then just sort of like go back and get very close to what they have. See, they give you, sort of like, let's say right there, right? So align that with the pole. So if I kind of look at it, it seems like exactly that's what I have. Then if I reset this, then I play that. Okay, so I'm gonna get something like that. So then you go down and then choose which one of those numbers are much closer, and you can see it. You have 3 submissions. That means the goal here is to just make sure that you're doing it correct. And then it, somewhere over here, it tells you what is the length of one car. It says the total train length is 15.5 meters, and the individual cars are 2.5 meters long. That means this is the time it takes for it to cover one car equivalent distance, which is 2.45 meters. Distance over time will give you then the speed. So you calculate and make sure that you're doing it correct, because again, well, 3 submissions, you hopefully get the right answer. Okay. All right, so any questions about the timer and then finding the speed?
Yes, you said, so after you have the time that it takes for the cart to pass from the 4th cart to the front of the 5th cart, you divide that by the length of the roller coaster cart?
No, you just basically know that you covered one car equivalent distance, right?
Okay.
And that distance is 2.45 meters.
Okay.
Then you measure the time it takes for it to cover that distance, then distance over time gives you the speed. All right, so then another thing will be to learn how to measure the radius of that, 2 individual circles that we have, right? That means the bottom one. So remember, as I said, right? So there are 2 circles that we're dealing with. So then the bottom one has, basically this shape. So pretty much this shape. The top one have this shape. Okay, that means we can align our protractor with that particular, circle that we have. So for example, see if I bring this one and put it there, see it doesn't match the circle that I have. So what we can do though is we can drag it, make it bigger, and place it back in case, right? It's still not matching, right? Because it at least, you want it to at least that, the protractor to match from here to there, right? Basically that shape. Okay, maybe do it with a different color. Let's see if I do blue. So I guess this is what we want. All right, so then align again, so the protractor may be bigger. Okay, so again, see if I just put it there, it's still not enough. So you drag it, you drag it, you drag it until you put it there. Eventually it matches. So see, this is already getting much closer. There you go. So I think this is basically almost good enough that we can do that. So then you take that. Oh, okay, so you can say that protract. I mean, I guess move the protractor first away from that. Okay. So here's then the protractor. All right, so hopefully you guys can see, right? It basically nicely matches that bottom part of that, let's say the roller coaster. So it matches nicely that the circular shape at the bottom. Then I take, let's say, one of them. Maybe this one is better. And then just put it from at the bottom to all the way at the top. You can see, right, those, sort of like, let's say you have these lines to help you with that. So for example, there's a line like this, or the cross, that means start from there all the way to here. That allows you to get, left or right. So right now we want these ones, these lines. So then I put my ruler such that is, no, that's not what I wanted. So I didn't need any curvature to that. Okay. So then if I take it, basically somewhere from over here to that, so then measure the distance. Okay. So can anybody read what you're seeing? So what do you guys approximately, what do you read for the length, for the radius?
6 centimeters. Wait, yeah. No,
Well,
sorry.
Yeah, so that means you can see, right? It's basically goes up to 20. And if I place it like that, so that means you have to subtract, right? So basically 20 minus 6. So what we get, it's about 14 meters, right? Because what we want is that length.
So Professor, it looks like you're putting the ruler kind of like in the middle of the roller coaster and the bottom of the protractor, or should the ruler touch the bottom of the protractor, or?
Well, it is from the bottom of the protractor, right?
Yeah, yeah, I was just making sure because it seems like
it is at the bottom of the protractor. That's
okay.
where my protractor is. And then I'm measuring the distance from the bottom of the protractor to that, basically a line at the center. So what do you guys measure as the distance between those two lines at the bottom and the center?
Yeah, I would say 14.
Yeah, roughly about 14, right? Exactly. Because, you see 6, but 6 is basically starting from the top. So what you do here is, because it's a 20-meter long, that in the particular ruler, right? So you can subtract 20 minus 6 to get roughly 14. Or you can say that we want basically that particular distance. All right, so hopefully, you guys okay with that? Okay with about 14 meters. So again, you need to do a little more accurate measurements. I'm just giving you the rough, estimation. All right, so that means that's how you measure this one. And then the same way you measure the second one. Now you just make it smaller and just place it there so it matches the curvature of the top one. For example, if I put it here, right, you can see it's not matching. So I need to make it smaller, 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 smaller. Put it back. I made it too small. Not quite yet. All right, so it seems like perfect, right? So this one seems perfect, matches that curvature. Again, you take then the ruler. This one you can technically start from 0 to the top and then measure what you see. That means measure the radius. You can measure diameter divided by 2, but you can just directly measure the radius of that top one. All right. So that's basically how you measure. And pretty much after that, you just do some measurements, and then you do after that you just do some calculations. The idea here is then understand basically how those things are related to one another, right? So for example, if you're talking about this particular cart, let's say, okay, so here's let's say the fourth cart, right? So the fourth cart, when it's at the bottom, you need to understand that what we have here is there is then this gravitational force mg, and then there is a normal force n, right? So imagine you're sitting in that car, right? So that means you have, or think like this, the car itself, right? Basically it's pushing down on the rails, right? So it has a weight mg, and then there's a normal force, n. But it basically goes to have a net centripetal force upward, which means you have an n plus, sorry, and minus mg equals mv squared over r at the top. Okay, and when you're at the top over here, see, like let's say you're upside down. So where then the force, normal force, and mg both acting in the same direction. So n plus mg equals an mv squared over r. Okay, so this is the equation at the bottom. This is the equation at the top. And then the idea here is that it's asking to find mg, oh, so sorry, normal force as a multiples of mg. That means, you know, the idea is that once you find the normal force, right? So let's say, because you're not given the mass of those things. So, but you'll be able to tell, you'll be able to, you know, able to figure out, I'm hoping you'll be able to figure out how to represent n as a multiple of mg. Okay, so basically at the top and at the bottom. So what is n as a multiple of mg? That means your goal will be to figure out that. All right. Any questions? So those are what you need to do to take the experimental data. Remember, Rollercoaster, this graph, sorry, this video specifically to do three things: find the distance or the time for one car equivalent distance, so then you can use that to find the speed, and then measure the radius of those bottom, let's say, circle and the top circle. So you need two radius measurements, and then you need two distance and time measurements to find the speed at the bottom and at the top. So at the top, you just do exactly the same thing. That means you just choose one of the cars, let's say the fourth one, and then measure how long it will take to cover one car equivalent distance, and then you'll be able to then measure the speed. All right, any questions on all this?
Yes,
Sorry, what was the capital N again?
N is basically, for example, if I go down, let's see, for example, number 6, right? So it says determine apparent weight. Well, apparent weight is just another name of calling normal force. That's just another name for the normal force as a multiple of their weight mg. So that's why you can think of like n is that multiple number of mg, because is normal force going to be 5 times mg or 2 times mg or 100 times mg. So it's asking you to give you in terms of that. So that's why you can take n to be that, you know, certain multiples of mg. And I gave you the equations. The rest, you know, I'm hoping you'll be able to figure out on your own how to represent, take the equation and how to represent normal force, which is another way of apparent weight. Is just, again, another way of representing normal force, which is another name for the normal force, to represent as the multiples of mg.
So, Professor, you said we pretty much just need to find the speed by doing it how you showed us with the length of the cart and the time that it takes to cover that distance, and then we also need the two sizes of the circles.
Yes.
Okay.
The radius. Yeah.
The radius, both the radius.
Exactly. Okay. Anyway, so I guess that's it. Again, if you have questions, you know, just basically, you know, feel free to email me or come to my office hours. But let's say, I think, at least in terms of measurements, I think I pretty much covered everything. So it just pretty much, you take the data, do the calculation, and then at the end, figure out or find out basically how many multiples of mg is your normal force. It's relatively straightforward once you do the calculations for the, let's say, the speed and the radius. All right, so let's say then that's it for this part. So then let me break you into